Hi, everyone. My name is Brett Carpenter, and I'm a Senior Director at Cox Automotive, where I have product responsibility for the data marketplace and model ops initiatives. And I'm here today to talk to you about building bridges and setting boundaries, 5 tips for successfully scaling AI. First, a little about Cox Automotive. We provide automotive marketing, sales, operations, inventory, lending, and fleet services, and we go to market through 13 brands. As a consumer, you may have interacted with us by visiting autotrader.com when you were shopping for a vehicle, or if you were researching a vehicle, you might have gone to Kelley Blue Book at kbb.com to find out more about it, what you should pay for it, or maybe what your trade-in is worth. Our data scientists develop AI models that support capabilities like our industry benchmark valuations products, Manheim Market Report and Kelley Blue Fair Purchase Price, as well as capabilities like risk management, personalization, fleet optimization, and market forecasting. Through our products and services, we touch 3 out of 4 vehicle sales transactions in North America. So where did we start? When we began this journey in 2022, we had approximately 60 data scientists operating with little to no engineering support, essentially an independent team. Those data scientists had diverse levels of experience, background, and skills, ranging from those early on in their careers who had grown up on open source to very experienced data scientists who were very skilled at using proprietary languages and technologies to do their jobs. This resulted in a real lack of standardization around technology and process, such that for any given model, the way it was developed was really an artifact of the experience and background of the data scientists that developed it. We had over 100 production models supporting key products and capabilities. And when it came time to deploy a model in production, the data scientist could choose to own and operate it themselves, in which case you had a data scientist spending time operating a model instead of enhancing a model and developing new ones. Or they might throw it over the wall to engineering, who in turn might decide that they need to refactor it in order to support it. And beyond that, it became very difficult for the original data scientist to ever update it. The end result of a lot of this was friction and an inability to scale. And the overarching goal of this whole initiative was to drive innovation by creating a culture of experimentation. Our leadership often tells us, fail fast. But in order to fail fast, you need to be able to move quickly. So this is really a story of learning how to move quickly, but also to do it safely. So what was our solution? Build a strong foundation. Let data science drive innovation, put up some guardrails, make the road smooth, and lead the way. So I'm going to tell you about each of these. First, build a strong foundation. Our leadership team made the decision to invest in engineering staff to form a ModelOps team fully dedicated to supporting data science, and also to acquire a platform that met the needs of data science and ModelOps. And this platform needed to unify those teams, like Dataiku. We knew we needed to solve for the full model lifecycle and not just the workbench. A lot of tools index towards model development or model operations, but not both. Dataiku does a very good job of addressing the needs of both engineers and data scientists. Lastly, we knew we'd need to define clear boundaries for data science and engineering. Data science would still retain full controls over the model that they develop, yet engineering would now be responsible for the operation of the platform and the ability of other teams to integrate with those models. Let data science drive innovation. One of our goals has always been to maximize the flexibility afforded to our data science partners. And so when we were getting started and focused on adoption migration, we knew we needed to meet data science where they were. And where they were was code first. But that was fine, because Dataiku makes it very easy to be code first. So our data scientists could come in and work in a notebook or a code studio and immediately be very comfortable. This also made it easier to migrate existing models to Dataiku because it minimized the amount of refactoring we needed to do in order to migrate. And then, as our data scientists became increasingly comfortable with Dataiku and its capabilities, they became comfortable using visual tools. Notably, The data pipelining tools that Dataiku offers, they generate very efficient SQL. They make it very easy to push that SQL down to the database, and it's really improved our processes. We want to provide a lot of autonomy to our data scientists. We do not restrict the kinds of models they can build or the kinds of packages and libraries that they can use. We don't curate a list of acceptable packages and libraries. Data science chooses them. And if they run into a problem, then we resolve that when it arises. Lastly, experimentation. We know we want to promote it and get better at it. The best way to do that is through self-service deployment. ModelOps gets out of the way, and data science has the ability to deploy models when and however often they want to. We did need to put up some guardrails, but we were selective, only doing the minimum required. We implemented a formal model development lifecycle. Software engineers have used a software engineering lifecycle for a long time, and we want to take the best of that and apply it to data science. So we did two big things. We created segregated development, staging, and production environments, and we enforced the use of version control, both Dataiku and version control, as well as integration with GitHub Enterprise. We standardized data pipelines by requiring that all models read data from and write data to our data marketplace, which is built on Snowflake. Every model has its own dedicated output schema, and it writes to that uses its own dedicated Snowflake role. If a data scientist wants to expose one or more tables output by the model to our data marketplace and enter that data into our data catalog, they can do that using a custom Dataiku macro that we developed expressly for this purpose. So it's easy to use, and every data scientist is doing it the same way. Lastly, data science needs to comply with our enterprise change management process. Engineering has been doing this for a long time. If data science were to go and apply this process manually, they would need to attend change review meetings, get approvals, schedule deployments. We're talking about a lot of friction. By using our self-service deployment workflows, this is taken care of for them. We integrate a call to our enterprise change management API. Each model has its own component ID, and that is submitted as part of this API call, and the change is logged in our change management systems. So just by virtue of using our self-service workflows, data science is automatically compliant with enterprise change management policy. That's a huge win. We needed to make the road smooth so that it was easy for data science to operate within the guardrails that we defined. Why? Well, because if it weren't, there would be resistance to adoption, and our data scientists would likely find another way of doing things. They're very good at that. So we did a few things here. We created consistency with automated project creation. We built a Slack app that calls the Dataiku API to create a new project and to create a new code environment for that project. And it also calls the GitHub API to create a new repo for that project and associates it with the Dataiku project. This means that every data scientist that's starts off in the consistent same way. We avoid surprises with deployment readiness checks. We built a utility that, again, leverages the Dataiku API to interrogate a model and determine, have scenarios been defined for it so that the model will actually be scheduled to run in production. Have the proper environment variables been set for the model, like component ID, so that it'll comply with our enterprise change management process? Does the model have access to the necessary Snowflake tables and views it needs to function properly in production? So we catch these things ahead of time instead of at deployment time, or even worse, once the model's already deployed and it fails in production. And lastly, and as I mentioned before, we orchestrate deployment through self-service workflows. And we built all of this using Dataiku Advanced Govern. We built two workflows, one to deploy Dataiku flows, or what we frequently refer to as batch models, to production, and the other to take a model, containerize it, and make it available to engineering teams that want to incorporate that model into their system, say, for example, an API. The workflows also do things like obtain approval from data science leadership and product leadership prior to deployment. And as I said before, integrate with our enterprise change management process. Dataiku Advanced Govern also serves as our enterprise model inventory. We also were sure to lead the way through change management. When we first started out this journey, our data science partners were very concerned that engineering would simply choose a platform for them to use and give it to them, and then it would be up to data science to make it work. And we decided that we weren't going to do that at all. Our engineering support team, our ModelOps team, is entirely dedicated to making data science successful, to enabling them. And so we partnered with data science to define comprehensive requirements for the platform that reflected both engineering and data science needs. And when it came time to evaluate a platform, we did it together. This is where Dataiku really shined. Dataiku was very amenable to having us install their software in our environment and connect it to our data so that we could execute 3 very Cox Automotive specific use cases using Dataiku. And what this did is it gave us a really clear idea of what it would be like to use Dataiku to do data science, and then what it would be like to support it as a platform. Our Dataiku sales engineer made herself available throughout the process, conducted coaching sessions, answered questions, and made sure we stayed on track. So we also got a really good idea of what it would be like to partner with Dataiku in the future. And the answer was, it was good. So when it came time to make a purchasing decision, it was much easier. We have delivered comprehensive training to our data science team. We had Dataiku conduct 2 live training sessions when we first onboarded to the platform. And now, when a new data scientist joins the team, they're required to take a series of classes at Dataiku Academy, Dataiku's online library of trainings. And we have found that to be extremely useful because it means when the data scientist onboards to the platform, they already know generally where to go and what to do. And in turn, that's made not only our lives as ModelOps easier, but also our data science leadership's lives easier too, because their people are better trained when they start working. Lastly, we have really strived to provide white glove support to our data science partners. We are extremely responsive and thorough in answers to questions about how Dataiku or the ModelOps platform works, providing guidance on how best to build models, how best to build data pipelines. And this has done a couple things. It's helped us achieve the adoption and migration that we want, but specifically, it generated a tremendous amount of goodwill because it made it clear that ModelOps was dedicated to making sure that data science was successful. And what we were asking our data science partners to do was very complicated. Change the way they work, migrate over 100 existing models, all while continuing to do business as usual. So anything we could do to foster goodwill was well worth it. And support was a good way of doing that. So where did the road take us? Well, since inception, 2 years ago, we've migrated over 100 models to Dataiku and retired 2 big legacy systems. In 2024 alone, we released 55 models to production and 197 updates. So there's experimentation. And we realized a 70% decrease in deployment time from months to weeks. And the thing I really want to call out about this is deployment time is now driven by data science's work cadence. It's not driven by idiosyncrasies of the platform, technology, ModelOps. So data science is in complete control, and ModelOps has become more and more transparent to them over time, and that's the goal. So in conclusion, what did we do? Well, we built a strong foundation by investing in a team and a platform that unifies data science and engineering. We let data science drive innovation and really maximized the flexibility afforded to them. We put up some guardrails, but only where necessary. And we made it a smooth road so that it's easy to operate within these guardrails, largely through automation. And we led the way with great change management and training. And so I feel confident that if you follow these principles, you will likely be successful as you go about scaling AI. Thank you so much for your time. I hope you found this useful. Take care.